for chapter 15, and it's really just covering up through the first lecture. So I think 15.2. Did you guys have any questions you wanted to ask about before we pass this out and start? At this point over the weekend, you should have done the 15.1 and 15.2 homework. That was 1 through 36. Do you have any questions from that assignment that you want to ask about before we start the homework quiz? I know it's been a few minutes since I've seen you guys because you weren't here last class, which was the original date for the homework quiz. This is me trying to give you an opportunity to ask about something if you're walking in and going, do we have a homework quiz today?
You just do an example.
An example of?
Something we should know.
Well, I would like you to maybe look at, for example, the homework problems.
Can you go to the problems and kind of highlight important things so I can see if I got it down? Is it gonna be on the percentage stuff? Like that?
So it's up through 36.
So that's what we'll do this weekend, we're making 36?
Yep.
Oh, nice. And then the rest is due this weekend?
Correct.
That's a lot of numbers.
It was, but you'll have all the rest of today to work in class. Which is something. It's not nothing. 15, absolutely. So 15 says the population in millions of people. Actually, let me do this real quick. Let's do that. Of Ohio, T years after 1900 can be modeled by the equation P of T equals yada yada yada. Based on the equation above, when was the population of Ohio? 10 million people. So all we really need there is to solve the equation P of T equals 10 million. Now, I'm told in the problem that P is in millions of people, so really all I want to do is solve P of T equal to 10. So to do that, I'm just going to use my calculator. So into Y1, I'm going to type my equation for P of T that's given to me in the problem. Gosh, it's so stupid. This one should need to be 10. That's supposed to be the denominator, though, you maniac of a machine. Okay. So I have that, right? Now I need to set a window. So T is time, right? T equals 0 represents the year 1900. I know the population of Ohio is currently over 10 million people, because how could it not be? So I'm going to put 100 there, because that'll represent the year 2000. I'm guessing somewhere in between 1900 and 2000. Ohio would have tipped over 10 million people. The Y scale, I know from recognizing this as a logistic function, has two horizontal asymptotes, one at Y equals 0, so that'll be the Y min, and the other at Y equals 12.79. So I'm going to use 13 as my Y max. And then I'm just going to hit graph. So there's my logistic function. There's 10 million. That's the point I'm interested in. So second trace, intersect command, enter, enter, enter. So T is 69.7, let's say. So we got it about the year 1969 would be the year in which that happened. Avery, does that feel okay? Okay. Is there others that we want to look at? 5, sure. So 5 says determine the formula for the exponential functions whose values are given in the table below. So here's my x's and my f of x's, because I'm writing the equation for f of x. So first thing I'm going to observe is that I have x equals 0. Immediately what that gives me, well, let's start earlier. Since I'm writing an exponential equation, I know I want something that looks like this. Since I have a point where x equals 0, immediately that tells me that the y-coordinate when x is 0 is my a value. I get that for free. Now I'm going to use the point where x is equal to 1 to solve for b. What do I get when I multiply both sides by 2/3 to get b by itself? Or think about it as dividing both sides. Good, 1/2. So I have a and I have b, so that's everything I need to write my equation. And I'm done. Does that feel okay there?
Is there gonna be one or is that a 0?
I mean, there could be. I mean, that's what you see in questions 5 and 6.
I mean, like, no. Like
Right.
7
I'm sorry, 7 and 8. Yeah, sorry. I said the wrong numbers. Could happen, sure. Happened in the homework. We did in class in the notes. Sure, which one would you like to do? 8. Okay, so we're looking at that one. So here, because we're not given a point where the x-coordinate is 0, what I'm going to do is I'm going to start by writing a system of 2 equations. So I'm going to plug in my x and y. I'm going to think about the first one as equation B and the second one as equation A. Reagan, you okay with what I did there? So to solve this system, since the variables are being multiplied, I'm going to be dividing the 2 equations. I'm always going to pick the equation with the bigger exponent to be the numerator of my division problem. So I'm going to have 32 over 27 divided by 16 over 9 equals a times b to the third over a times b to the second. How do I divide 2 fractions again, like 32 over 27 divided by 16 over 9? Nope. So you multiply by the reciprocal. So the one that's doing the dividing, we just kind of flip. Now what do I get when I have 32 over 27 times 9 over 16? Well, 16 goes into 32 how many times? Twice, right? 2 times 16 is 32. How many times does 9 go into 27? 3. So I have 3 over 2. Or I'm sorry, 2 over 3. Yikes. The a's reduce, right? What's b to the third divided by b squared? B to the first, right? So there's my B. Awesome. What do I do with that now? I plug it into either spot to solve for A. So I'll plug it into, say, equation A. So how do I do 2/3 squared? How do I square a fraction? Yeah, you square the top, so 2 squared is 4, and you square the bottom, 3 squared is 9. Anybody see what A is without having to actually do the division? Yeah, good. So A is 4, and that's all we need, right? So we have y equals 4 times 2/3 to the x. Does that feel okay, Regs? So again, not massively different, but a little bit. You have that system to solve, right? But if you can usually get the system set up, it's usually not so bad after. What do you guys think? Happy to take some more if you got some more. Going once. Going twice. Okay, quiz time. Any mistakes?
I'm perfect, so. Can I go to the bathroom, Mr. Clue?
You may. Oh, that would be embarrassing. Jack Rose. No! First question. Fluid.
I need the track.
Okay, wait, I'll check. Okay, I'll
Perfect.
Oh, boy. We're almost there, guys.